section 6.4 is about the endomembrane system. So remember that eukaryotic cells have a lot of membrane-bound organelles, and that prokaryotic cells do not have these, and this is what we're talking about here. In addition to the nuclear envelope, which we just learned about last section, these are all of the membrane-bound organelles. And so inside of a cell, there's a ton of membranes, and these are made up of the phospholipid bilayer, like we talked about, and like you've always learned about as a cell membrane, but there's way more membranes than just the cell membrane. And they're all kind of connected. And so this is how they work together. And that's what it means by endomembrane, because they're inside of the cell membrane, side of the plasma membrane. And these consist of the nuclear envelope, like I just said, the endoplasmic reticulum, which we can usually refer to as the ER, the Golgi apparatus. You might see it as Golgi bodies or Golgi complex, same thing. Lysosomes, vacuoles, and the plasma membrane. And like I said, these membranes of the endomembrane system are all continuous. So they're all connected to each other by actually being connected, or by these little things called vesicles. Vesicles are little tiny membranes that store things inside of them. They'll pinch off from one part of the membrane, travel to another, and open up into the new part of the membrane. So that's really important to know also. Okay, so not all membranes are the same that are inside the endomembrane system. So some of them have different thickness, or they have different kinds of proteins on them. They do different kinds of chemical reactions, but in theory they're made up of the same stuff, and they can all connect together. That same stuff being a phospholipid bilayer. And they can also change over the course of a lifetime. So your membranes of one part of your cell might start off doing a lot of one kind of chemical reaction, and as you mature, they could change to something else. So the first one we're going to talk about is the endoplasmic reticulum, and this is called the biosynthetic factory. And so the endoplasmic reticulum takes up a ton of space inside your cell. It accounts for more than half of the total membrane in a lot of eukaryotic cells. So that's a lot, because we listed all of these things as being part of the endomembrane system, but the ER takes up more than half of all the membranes. And the ER membrane is actually continuous with the nuclear envelope. So do I have a picture? Okay, so you can see here, here's the nuclear envelope right there. There's all the pore complexes. You can see, like right here, that it's actually connected. So between the double membrane of the ER, it's actually connected to the inside of the double membrane of the nuclear envelope. And there's two kinds of ER, smooth ER and rough ER. Smooth ER is smooth because it doesn't have ribosomes on it, and rough ER is rough because it is covered in ribosomes and looks bumpy under a microscope. Endoplasmic means within the cytoplasm, and reticulum means little net. So there's just very vast expanse of endoplasmic reticulum throughout the cell in the cytoplasm, and it's very diverse and spread out, so it's like a net. So here you can see it again. So here's all the ER. The space in between the ER, so you can see it labeled right there, is called the ER lumen. And so that's the space inside of the endoplasmic reticulum, and that's where all this stuff that we're going to talk about, it happens inside the lumen of the ER. Over here is the smooth ER. You can see that there's no ribosomes on it. And over here is the rough ER. And again, you can see here that the lumen of the ER connects to the lumen, or the intermembrane space, of the nuclear envelope. Okay, so Okay, functions of the smooth ER. So the smooth ER does a lot of things. It synthesizes lipids. It metabolizes carbohydrates, so breaks down carbohydrates. It detoxifies drugs and poisons, and it stores calcium ions. So let's talk about each of these things. So there's enzymes found in the smooth ER that make these lipids. A lot of these are steroids, which most hormones are steroids. Remember, steroids are those ring structures that we talked about, not the other structures of the fatty acids and the glycerols. Steroids just are a bunch of rings, and they often act as hormones or chemical messengers, and they're made inside the lumen of the smooth ER. So cells that secrete a lot of hormones are going to have a lot of smooth ER because form fits function, so it's going to be structured in a way that helps its job. So if it has to make a lot of steroids, it's going to have a lot of rough or smooth ER. That way it can make a lot of steroids. So the lipids are made inside the lumen, and then they're secreted. So for example, your pancreatic cells, their job is to make insulin, or a lot, that's one of their big jobs, and so they have a lot of smooth ER. That way they can make a lot of insulin. They also detoxify drugs and poisons, especially in your liver cells. So your liver cells have an awful lot of smooth ER as well. What it does is it adds a hydroxide to the drugs. That way they can be more soluble into your water. So if we add a hydroxide, now we're adding something that water can hydrogen bond to. We're making the substance more polar by adding an OH, and now it can dissolve better into the solutions in your body and get rid of from your body faster. So that's how your body detoxifies drugs. And what happens is things such as barbiturates, alcohol, other drugs, they make your body starts using its smooth ER to get rid of them, and your body starts making more smooth ER so it can get rid of it faster. This is where tolerance to drugs and alcohol comes from, because if you are drinking a lot, your body's going to be like, okay, I need more smooth ER to help detoxify this alcohol that is being put inside my body. And as you do that, now it takes more alcohol for you to feel the effects of alcohol. So that's how a tolerance builds up. And actually, a tolerance of to one type of drug may lead, you're going to increase your tolerance to everything, because now you just have a lot more smooth ER. And your smooth ER isn't particular to one drug. It's going to do the job for everything. So if you build up an alcohol or a tolerance to one drug, it's going to affect your tolerance to any other drug. And this can be really dangerous because if you have a ton of smooth ER because you're a heavy drinker, and then you need to take a drug for an antibiotic or for something else, like a medicinal drug to help your body, it's going to be gotten rid of really quickly because your body can metabolize it so fast because it reacts in the same way it does to alcohol. So that's not very good. Another reason to not drink. And then the smooth ER also stores calcium ions. So calcium ions are involved in the contraction of muscles. So what happens is they're stored and they're released quickly, and it helps your muscles contract. And so so there you will find a lot of ER or smooth ER in muscle cells. Then we have the rough ER. So remember, this is the endoplasmic reticulum that has ribosomes on it. And these ribosomes secrete what are called glycoproteins. Glycoproteins are proteins that are covalently bonded to carbohydrates. So we have these proteins, and they just have a carbohydrate on them. So covalently bonded means that they are sharing electrons because they're an organic molecule, so they're going to be covalently bonded and not ionically bonded. And okay, so the job of the rough ER is to make these proteins and then package them up as well. So they're made on the ER, that way they can be made into what's called transport vesicles. So let's flip back to this picture. This right here is a transport vesicle. It's a little piece of the ER that's pinched off and is now being sent someplace else inside of the cell. So we can't just send things off inside the cell and assume they're going to go to where we want them to without packaging them up first, and that's the purpose of transport vesicles. So any protein that's made by the ribosome on this rough ER is going to be sent off in a transport vesicle. And this is so that they can be released into the bloodstream. So this would be any sort of secretory protein, things that need to be secreted. A lot of these are glycoproteins. and the carbohydrates get attached to the glycoprotein in the rough ER. So the proteins are made on the rough ER, and now they're inside the lumen of the ER, so they would be in here. So this ribosome would have made it, let it inside the ER, and then the enzymes inside of the rough ER are going to add the protein, make the covalent bond onto the carbohydrate. So then we have a mature glycoprotein. So the proteins that are made on the rough ER are different than the proteins that are made by ribosomes in the cytoplasm. So ribosomes that are in the cytoplasm are going to be used inside the cell. That's why they're made inside of the cytoplasm. That way they can find their way to wherever they need to be. Secretory proteins, or things that are made to be used outside of the cell, such as a hormone like insulin, because the cells in the pancreas make insulin and then they send it to your whole body. So that would be a secretory protein. These guys are made on the rough ER. That way they can be packaged up and sent off right away through the use of a transport vesicle. So that's really important to know. So whatever's going to leave the cell needs to be packaged in a transport vesicle. And so they are made, and then they are sent off in this place called the transitional ER. So the transitional ER prepares whatever was just made to be sent off and do a different job someplace else through the transitional ER. So it's so you should know smooth ER, rough ER, and then transitional ER is where they are made to be sent off.